Hi, friends. How's everybody doing? I wish I could see you like you could see me. I am coming to you live from my kitchen table here. What we're talking about today is how temperature, pressure, and volume are related. And this is going to be sort of our focus for the whole entire week. And we're going to do a lab on this also. The way these are related are by two laws called Boyle's Law and Charles' Law. Okay, so I have a couple of things for you. I'm going to show you a few videos, and then once I show you the videos, I'm going to write some notes. Okay? Hope you enjoy. Whoops. Okay, here we go. All right, so the first thing that we're going to do is we're going to look at what happens as the volume increases, what happens to the temperature. Okay, so I've got a quick YouTube clip for you here. What this guy's got going on is in the bowl, he's got liquid nitrogen. Liquid nitrogen is very cold. So we're going to watch him as he blows up a balloon, and he's going to dip the balloon into the liquid nitrogen. Okay, so as he takes this balloon and puts it into something that's very, very cold, what happens to the balloon? Okay, well, hopefully you are saying to yourself that the balloon seems to be getting smaller. So as the temperature decreases, the volume decreases. Okay, now he's going to take it out of the liquid nitrogen, which he should totally be wearing gloves when he's doing this. But anyways, as he takes it out of the liquid nitrogen and the temperature increases, what we see is that the volume is also going to increase. Okay, and he's going to do this again, but we are not. So what I'm saying here is that as the volume increases, we find that the temperature also increases. Okay, and again, the reason for this is as the temperature increases, see how my typing is while I'm talking. So as the temperature increases, what we find is that the molecules have more energy. They're moving around more. Okay, and as they move around more, they're sort of pushing on the walls of the balloon, and they are going to expand the balloon. They will push on the walls of the balloon and expand the balloon. So what we see is we see that as the temperature increases, we should see that the volume is also increasing. Make sense? Hopefully. All right, the next thing we're going to look at is what happens when we change the volume and the pressure. Okay, so what we have here is we have one happy and one sad marshmallow, and there's something called a vacuum pump. Now, what a vacuum pump does is it pumps out gas that's inside of here. So inside of here is all sorts of gas. So what this is going to do is that this is going to pump out the gas, and basically it is going to decrease the pressure. Okay, so when this decreases the pressure, let's take a look and see what happens to the volume of these marshmallows. Are you ready? Okay, so here we go. We are decreasing the pressure in here, and we see that the volume is increasing. Okay, now what happens when we increase the pressure again? Okay, so when we basically stop pumping air out and put air more back in, we see again the opposite happens. That is, we decrease the pressure, as we increase the pressure, the volume is going to decrease. Okay, so what we saw is that as the pressure decreases, we saw that the volume increased. Okay, so again, as pressure decreased, we saw that there was more freedom for the marshmallows to expand. Okay, so the molecules moved apart and expanded. Think about you personally. When your parents decrease the pressure on you, okay, you're more likely to move around more. Okay, so again, when the pressure decreases, the volume increases. Okay, last but not least, what we're going to take a look at is as the pressure increases, what does the temperature do? Okay, so last one here. We were watching this guy do an experiment, and in this experiment, he's taking water and putting some cold water into a bowl. Okay, the fact that it's cold is very important. Now this guy is taking and putting some water into a can. So he's filling it up with about 100 milliliters, which is not a ton. Then he's taking and putting this can with the water in there, which is totally a bad camera angle, and he's heating it up on the stove till it gets really, really hot. Okay, then what we see is that, okay, so what we see is that when he's taking that hot can and he's putting it into the cold water, we see that as the temperature decreases, the pressure is also decreasing, which causes that can to crush. Can you do this at home? Absolutely. With proper safety. Okay. So what we saw is as the temperature decreased, okay, so he put it in that cold water, the molecules were moving slower, sort of like my computer, moving slower. Okay, so they're not hitting the can as much, okay, which caused the pressure to decrease and the can to crush. Okay, so we saw as the temperature decreased, the pressure decreased. The opposite would also be true. As the pressure increases, okay, the temperature increases. Okay. All right, thanks, friends. I enjoyed talking to you, and we will hopefully see you soon.